Welcome to MLOps Live, a podcast by Neptune.ai. Today we have a special episode with our CEO, Piotr Niedźwiedź. Every couple of months, Piotr dives into a one-on-one discussion with an expert practitioner doing machine learning in production. Tune in for a no-fluff, in-depth MLOps conversation.
Hi guys, it's a pleasure to meet you all. I'm your host, Piotr Niedźwiedź, CEO and co-founder of Neptune.ai. And today I'm happy to introduce you to Simon. Simon, can you help me with your last name?
Of course, yes. Thanks for inviting me. My name is Simon Stiebellehner, if you want to go for the proper Austrian pronunciation.
That's why I need your help. So I found Simon over internet when I was studying MLOps market in general. What I was looking for ML people with MLOps engineer in title, and was curious about their background. And Simon's profile looks super interesting for me because have a quite, I would call it, diverse background. I've also read some of your blog posts, and yeah, it is how I came to the idea to invite you to this podcast. So Simon, if you can, for a starter, tell us a little bit about yourself, how you get into your current role, into MLOps engineer position, and how it started.
Sure. Yeah, so for me, indeed, my background, looking at my profile, looking at my career stations and academic stations, indeed, it does look quite diverse. I originally started out academically, really more on the algorithmic side. So first in my bachelor's, I focused on a mix between computer science and business. Then I spent some time in strategy consulting. So actually a lot on the business side. Well, a bit tech focused, but still a lot on the business side. And then in my master's, really specialized in a very algorithmic side. So actually really classic machine learning. And back then also with a few courses on deep learning, essentially. That's what I spent my master's with. And subsequently went for a PhD on the computational advertising side. So basically thinking about how can we use machine learning to solve specific problems, classic problems of online advertising, such as, click-through rate prediction, user behavior modeling, and these things. Well, I quickly learned that I'm too impatient for academia. I need stuff that moves fast. And of course, right, in academia, it definitely has its pros and really a beautiful side, but also it was a bit too slow for me. So I decided to change into consulting. So I joined a tech consulting company focused on building industrial AI solutions and the data platforms powering these solutions. So that's actually how I started out as a data scientist, building machine learning models that solve classic industrial use cases, predictive maintenance, predictive quality, visual inspection. Yeah. Then step by step, I took over the lead of the data science team in there. I also started, doing public speaking and all these things. And that's also where I kind of got hooked then in MLOps, because what we discovered back then in 2017 was, building the models, and it's not that much of the problem, right? You can solve many of, given data quality is fine, and given a few other things, of course, that are not always easy to fulfill. The model building exercise is often not the most difficult ones, at least when it comes to creating value. That's what we saw. So we sat together and thought about, how could we help our clients really get value out of these machine learning systems that we've built? And there we found that, it's really this gap when it comes to productionizing a model, when it comes to maintaining that model, operating that model over longer periods of time. That was 4 or 5 years ago. So back then, that really was a major issue. So we started developing a deployment and serving platform for machine learning models. And that was actually really, really, I think, radically user-oriented. We said, as a data scientist, you know how to use a notebook. The only thing we're going to ask you to do is package it up as an ML flow model, drag and drop it into our platform, into a web app. And we're going to take care of deployment. We're going to take care of serving. We're going to add a monitoring layer on top of it. And that's what we did. And that's also how I fell into the MLOps field a couple of years ago. And until now, it never really got out. Then moved to the Netherlands, actually from Austria, joined the largest e-commerce company here, still larger than Amazon, actually, in the Netherlands. And there I was a bit more on the algorithmic side again, focused on building large-scale language models for understanding our users. And after that, well, I joined where I'm now, really deep in an MLOps position. I'm the lead MLOps engineer for Transaction Monitoring Netherlands, which is not a classic fintech startup, because we are a joint venture of the 5 big banks of the Netherlands with the goal to fundamentally change how anti-money laundering monitoring is done. And here I have kind of two hats. On the one hand, I'm lead engineer in the MLOps platform team. And on the other hand, I'm also craft lead for the machine learning engineers actually working in model development teams, people that develop models. That's where I'm now, and that's kind of my journey.
So looking at your backgrounds, on one hand, for me, what is to some extent surprising is that on one hand, it looks like you have strong algorithmic, like this, maybe you can call it academic knowledge about data science, about ML. But on the other hand, your title has MLOps engineer inside, right? So it
Correct.
sounds way more closer to engineering. And there is in this space, there are different way of defining roles in ML team. So looking at your current role, MLOps engineer or head of such team, who is MLOps engineer? And how is it different from, let's call it, ML engineers?
Yeah.
What's your take on that?
That's a very good question. And I think that's also something that you find currently discussed on Reddit. You find it discussed pretty much everywhere because it's a hot topic and people also really love to talk about role names.
But what is the job to be done for putting names aside? What do you do?
Yeah.
What your team is doing?
So here at TMNL, we thought about the two roles in a way that we do make a difference between these two roles. And that's also how I think about it. And I think it's also important to make a bit of a difference, especially when it comes to targeting the right people in hiring. That's, I think, what's really important. So the way I see it and the way also we do it at TMNL is that as an MLOps engineer, you are on the platform side of things. That means you're busy actually building tools and infrastructure to support, to provide capabilities that make model development more effective and more efficient. But you do that on a more generalized level. So that means you basically you try to understand how are we currently building models? How is it currently done? What are the pain points? What are the things where our platform is, too rough or doesn't support certain capabilities? And then you try to abstract away from that and build out that capability and provide it as part of the platform of our kind of internal product to the other teams that actually develop models. So that's kind of how we see the MLOps engineer. It's a lot more infrastructure focused. It's it's more a classic platform role, a classic platform team.
So who are the guys, the people who are users of what your team produces, of your platform? What are their positions?
Yeah, so the users of our platform are actually, it's internal users, our model, what we call model development teams. It's essentially classic data science teams. So it's in our case, cross-functional teams, usually a couple of data scientists, one or more machine learning engineers in there. That's also where I'm going to get to and how far is it now different? And then also a domain expert is in there, what we call an AML expert, a person who really knows about, how is money laundering actually done? How is it done? What can we do against it? That's usually how what we call model development team looks like. And these are the users then of the modeling platform. So what does that machine learning engineer in there actually do? And how might that profile be different from an MLOps engineer? The machine learning engineer, the way we see it, really works on a concrete manifestation of a model. So it's not that much about thinking about how can I build a generalized capability, or how can I provide a tool or a service to other teams, but it's really what we call stream aligned. He or she works in a stream aligned team, meaning the purpose of the team is to build models. These are the products of that team. So that MLE will be a lot more focused on building scalable data pipelines that fuel that model. That MLE will be a lot more focused on building some reusable components of the model that makes it easier for the data scientists to work and these things. So it's really more the working on what we say in the field. The person works in the field, whereas the MLOps part works on the platform.
Understand. And from manager perspective, if you are about to hire MLE versus hire MLOps engineer, let's assume I think it is a fair assumption that it is hard to find person with such title available on the market, and you need to get this person from, let's say, software space. Who are the closest profiles? What type of experience you would look for if you want to hire MLOps engineer versus MLE?
Yeah, that's a tough one. So for MLOps engineers, indeed, there are hardly people with profile name, that role name. I think more people have actually been doing it than you would recognize in the job title, because simply the term MLOps is still relatively new, and that's why. So what we usually look for is, there are two ways how you become an MLOps engineer usually. Either you approach it more from the DevOps side, and you say, okay, I'm a DevOps person, but I've been working together with model development teams for quite a while. I understand what building a model means, and I understand how data scientists work and what capabilities they need to do their work better. This is one way how that can be done. And the other way is then really more coming, and I think that was more my path, coming more from the data science, machine learning, engineering end, moving more and more towards the platform side. So being more interested, or thinking more about how can we solve problems in a very generalizable way? How can we build the appropriate tools? So usually when we try to hire MLOps engineers, of course, the wish would be we would find a person who already is there exactly at this intersection. That hardly ever happens, but it's then more, you can essentially come from both sides. If your interest is strong, to move more to the other side. So you also manage to, time after time, pick up the missing capabilities. That's usually how we do it. On the machine learning engineering end, it's a bit easier, I think, because there usually that role name has been existing for a bit longer. Also, the capabilities, the core capabilities, at least how we define machine learning engineering, have also been applied in practice a bit longer. So there we usually try to hire classic machine learning engineers, so to say, people who have built their production-ready pipelines, have built out their large-scale data pipelines and these things.
Got it. And when it comes to MLE, maybe last questions, because we are going deeper and deeper, but it is something that I've discussed a couple of times over MLOps community Slack that I recommend. When it comes to MLEs and the difference from software engineers, especially when we are thinking about not super senior, if you can have super senior ML engineer with 20 years experience, not really, right? But what do you think, taking into consideration that when you look at the typical, like how typical computer studies program today looks like, you have at least few subjects, courses on ML, on data science. Would you say, like, do you see that, maybe I would put differently, what is missing for, let's say, backend software engineer in order to be MLE? Do you see something that is really needed to fit into this role of MLE?
Yeah, actually, I have, in my previous job, I worked together. I was kind of, it was called expert machine learning engineer, which is essentially a staff engineer for machine learning. I worked together with one backend engineer, coaching and mentoring him because his desire was moving towards machine learning engineering. So what I saw there, what is missing from a classic backend engineer, very often backend engineers are still, the primary focus is still Java. So often there it already starts that the dominance of the programming language is quite different compared to what is being used in machine learning. So that's usually the first gap where it starts.
So they're missing Python.
Often, yeah. Of course, there are also backends in Python, but still Java is massive there.
True.
Right. So that is actually one gap where it typically starts, kind of just it's a different language. So that is one thing, an important thing. A second thing is then, I think that is similar to any role that is not very much data related. That is simply, how are the workflows you apply when you work with data? How are they different compared to not working with data intensive workloads?
Yeah.
Right. And there it's, right. I've had the experience when you show an engineer who has never worked on a data side, you show the person a Jupyter notebook and he's like, why the hell would you actually use that? What's the use case for this? So it's a lot about learning why do people work with data the way they work? So that is something that's often a gap. And then, of course, you need to learn at least a medium level how to build a model. Where can it go wrong? How do you do exploratory analysis? What are your most important statistical metrics? These things. So that's usually what you need to, I think these are the key 3 things that you definitely need to cover to transition. And I think what I usually recommend is have your pet project, of course. That's always the best, step by step. But also, especially when you work in a larger company, try to get to collaborate and get the foot a bit into another team that might need exactly your skill set, right? There are teams that have 3 data scientists, not a single engineer, and they're like, any engineering power and engineering thought would help us a lot. And that's usually a good entry point to start collaborating and getting more experience on that side.
Makes sense. And talking about teams of data scientists, there is another debate in the industry about where data scientists, how they should be placed in the organization, whether we should look for centralized AI team or platform team. I think it may be different if you look at MLOps engineers building platform, maybe different from data science team that is centralized versus what is called stream aligned teams. What is your take on that? Where, like, if you are, let's say that you became head of AI, I saw you that you've been head of AI in the past.
Yes.
And the CTO, the board asked you, okay, Simon, like, how we are going to build it?
Yeah. So starting out with your first data science use cases. I think that's a very different setting usually compared to, when you've been doing stuff for a while and there is awareness across the company. So I think when starting out, it's often a lot easier to start out centrally, have a look from a central point. What could be important data science use cases? Try to identify that with the other teams or departments, and then really try to focus on if possible, the low-hanging fruits that still provide considerable value, right? Go for that first. And I think starting out centrally is a lot easier there because the data scientists you hire, they will be together. Sending a data scientist somewhere as the first data scientist in your company into some team, that person is going to have a very, very, very hard time. So chances are that's something that often happens. You hire somebody, the person's placed in a lonely team and said, please do data science. And that person leaves again after half a year. So I think just from this perspective, centrally is a lot easier. Also, it gives you really a larger view, usually, a larger spectrum that you can operate in, looking around saying, what are really the high potential use cases? If you hire straight into one specific product, that's often a lot more difficult because you need to live with what the team is currently doing. So I think for starting out, a centralized version is usually fairly reasonable. The more you grow, I think the tougher this is actually scalable. It's tougher to scale, and also it's tougher to keep models productionalized and retain end-to-end ownership of these models. I believe the larger companies become, the more widespread data science becomes in the company, the more this should be embedded in product teams. That's usually, at least I'm a firm believer in, what you build in a team, you should own it and you should maintain it end to end, from POC all the way to production to operations. Because the knowledge, what this thing should do, that is in your team. That is not with a centralized team. So this is, I think, the larger you grow, the best default operating model. There are lots of shades of grays in between them, such as the way I think about MLOps and MLEs. There is one thing about building a platform, right? You cannot really do this decentralized. If you want to build a platform, you need to pull the appropriate forces together. But then there are also other things like enabling teams where you want to fast track certain changes, certain knowledge. You want to infuse knowledge into teams. Then you might also need to centralize a small squad, and that actually helps other teams accelerate in certain topics. But in principle, I think centralizing first, creating value, showing that stuff works, that stuff can deliver value. And then I believe the decentralization can come fairly automatically by teams starting to be aware and then creating a pull towards data scientists, actually.
It makes sense. To be honest, I have never really thought about it deeply, but I've spent almost my whole life in tech. And for me, always the more natural way was to go from the very beginning with what's called stream-aligned teams. But you said that when the understanding of techniques, of possibilities in the organization is low at the beginning, it makes sense to start from. And it is something that I've missed. I think it is a fair point. And the reality is that for the most organizations, initially, the understanding of a regular, of a random company is rather lower than higher, right? Not every company is Google. It makes sense. So let's say we have a team, okay? And you left academia to get your hands dirty, to be more practical. So let's be more practical. We want to get to production. We have our first model. How is it different? Because typically, if we look at the product teams, we would be looking at teams that already have some software developers. They have some existing, let's say, SaaS service. And today it is pretty clear and standardized how we develop software. So how is it different? Like not only develop, but also more importantly, operate software, right? The whole DevOps movement. How is it different when it comes to machine learning models? Why is it different? Those models are very often web services.
Yeah, I think there are some important differences, but at the same time, I think it's actually, things are not that different that many people want it to be, or the way that they at least the way that they say it would be. I think there are many commonalities, right? You're dealing with code, you need to handle artifacts, right? And these artifacts, that's data, that can be models, that can be whatever, Docker images, whatever you need. And handle that in software engineering, you need to handle that in machine learning as well. Of course, the volumes of data might be different, but also that is something we have been doing more in the context of data engineering for a long, long time as well. It's nothing that's also extremely novel. Also, the fact that you need to think about machine learning the same way as in software engineering when it comes to systems. You should never think about a model as one as your system. Your system is always broader. So I think that systems you need to have in software engineering, and you need to have it also in machine learning. I think the difference, really there are two fundamental differences. One is hardware requirements. Obvious one, probably as a classic software engineer, you are hardly gonna have a use case, maybe 1 in 10 years where you really need, some really heavy cheap GPU. That is one difference, but I think that's not the really important one. I think the important difference is actually the non-deterministic characteristics of that one artifact, of that model. I think this is actually this is the most important difference between classic software engineering and machine learning. You need to handle this often black box, often fairly complex black box. You need to handle it both pre-deployment and post-deployment. Pre-deployment, we speak about experiment tracking, right? It starts with not knowing what your model is actually going to look like. That's very different to how you usually approach software engineering. Here it starts. You start doing experiments. It's a very experiment-driven way of developing. This is one thing that's highly different, also requires specific tooling support, experiment tracking, tools, model registries, all these things. Then post-deployment, also this non-deterministic behavior of black box behavior put some special requirements on you. And there are many commonalities here, right? You need to monitor service health, uptime, response time. All these are things you're going to have to monitor either way, whether it's service without a model in it or a service with a model in it. However, right, you also need to monitor a few other things. You want to look at different forms of model drift. You want to look at concept drift. You want to look at data drift. You also that might not be so different, but you also want to have some data quality tests somewhere in there. These are special things that you need to account for, I believe. And that requires, right, monitoring a few, sometimes fairly expensive to compute statistical metrics, especially if you're operating on large data. Ideally, you also understand in the context of your monitoring solution, how does different drift actually affect my model? Not every drift is equal. These are things that I think that's really what makes developing machine learning systems very different then in that aspect from software engineering. But I think there are more commonalities than differences overall.
Okay. And you mentioned on one hand, model monitoring, right? On the other hand, data monitoring. I also read your blog about data dogs of tomorrow and have some follow-up questions around it. So maybe I will start from the end. How data monitoring? Let's say that we have data monitoring in place. We should go deeper. We should define firstly what data monitoring is. So let's do it this way. Mm-hmm. So what does it mean? What are the jobs to be done of data monitoring? Why we have it? There is another concept, data quality tests. How is it different? So if we can define those terms for us first.
Absolutely. So I think there are even the three terms: data quality test, data monitoring, and now, especially, I think in the last 2-3 years, data observability is a big topic. So data quality, that's what you build a data pipeline or you build a model pipeline, whatever. Let's say in your first job, in your first part, you load some data. And I think there it already starts. You want to validate some assumptions you have about that data that you're actually using in your model pipeline. And this validation of your assumptions, that's data quality testing. There are known things, known assumptions, and you want to test for them. So for example, your assumption is there is one column, say age of your customers, and that column cannot be null. You might want to validate that. And that is then what a classic data quality test.
Okay.
And then, well, right, you might fail your pipeline, you might not fail it.
By the way, is it based on, because this example you gave is based on one row, on one, let's call it item in sample, right? Would you consider data quality tests that look at the batch of samples, like distribution on one variable, or?
So both. I think it's whether you see it as on one sample in a, let's say, in a classic service deployed as a REST endpoint where really sample per sample is flowing in, or whether you see it in batch processing. You formulate assumptions as, you can call it tests or validations. And if these assumptions are violated, you want to act upon it in one way or another. So whether it's batch processing or in a near real-time service, at least I don't really make a difference there. And I think the jump to data monitoring is then, somewhat smooth. I think what the difference is not, I think, super hard. Same as between data monitoring and data observability. I see it more like a spectrum that we're moving in. The way that I see data monitoring is really that you have a relatively focused view on known relevant aspects of, let's say, your data pipeline or your service. That means you're focused on what is happening and when is it happening. So what is happening, let's say, a null value, and when has it happened? And then you kind of let that bubble up in a way in terms of you push metrics, you're saying, oh, we had 5 null values, you had 0 null values, you populate a monitoring dashboard. And that's how then you're using some predefined metrics, right, to provide some alerts. That's typically then what I would call data monitoring.
So kind of tracking and acting on results of those tests.
Yeah,
it sounds like that.
It's tracking and surfacing them and alerting, essentially. Right, and then you would get this classic alert via Slack or whatever saying your metric A has exceeded threshold X, for example.
Sure. So where is the drift here?
The drift between?
Where the data drift concept is in this picture.
Yeah. So when we look at data drift monitoring, what you could do is you would assess statistical. Let's make it simple. And let's say you have one pipeline, you have one model pipeline, a batch pipeline, and you run that once a day. What you would, for example, do is you want to compute a set of statistical metrics for a given variable. Let's stick to age of customers. So you compute different statistical metrics, right? You compute, for example, let's say your mean, variance, whatever. You compute that over time, or you use other tests such as KS tests or a PSI to see how these distributions change over time. And this is what I would see as data drift monitoring. You check how do the statistical properties of my input data, how do they change over time? And then again, if it exceeds a certain threshold, or ideally, if you know how it affects your model, if it affects your model, you would get an alert saying, hey, something is going to influence your model. So I think really it's only about, when we talk about data drift monitoring in the context of data monitoring, it's monitoring a certain set of metrics. But I would still put it into, of course, the field of data monitoring. It's monitoring a specific thing.
Got it. And follow-up question would be around model monitoring. That on one hand sounds like something separate, right? But on the other hand, if you look at model as a data transformation, like model evaluating inputs, producing outputs, yes, it is ML model, but you can think about this as a feature engineering from some perspective. So how, can you use, let's say that everything starts from data. We have data monitoring in place. Can you use it for model monitoring?
Yes, I've actually had exactly this debate a few times with colleagues as well. My opinion is absolutely you can cover a lot of use cases with classic data monitoring tools. A lot, right? Think about, and I've built solutions using classic stacks, right? Classic stacks such as Prometheus and Grafana, CloudWatch and Datadog, whatever, to monitor a lot of important aspects of your model. You do not, at least you do, for a variety of tasks, you do not really need specialized tools. But also, because, right, you can compute all your metrics you want to have, you monitor them, that's fine. But it doesn't mean that it's always the best thing to do, because it does require you to build things that potentially you could get out of the box using the appropriate open source library, using a third-party vendor, whatever, right? So this specialized model monitoring tool, think about Y-logs or Evidently and so on, there is an absolutely valid and very good reason why they exist and why they flourish, because they do make a lot of things for you a lot easier, a lot more reliable, and a lot more efficient often as well. Some things, of course, you could build it with your custom stack and using Prometheus and Grafana and everything. You can theoretically build anything, but it doesn't mean it's always a good idea because usually your job is not building that custom tool, but your job is a quite different one. Your company probably creates value in a different way. Yeah. And also then there are fairly complex features. These tools often come with like anomaly detection on top of your alerts, or even helping you understand how does a certain drift of a metric influence your model. All these are things that get really, really tough to build using non-specialized tools, actually.
Anomaly detection on top of alerts, it is something that I've seen in DevOps tools. But when it comes to understanding that this particular anomaly or this particular drift would impact your model in this way, it is something that I've not seen of course, in the classical software tools. I am curious how this will develop, because I'm asking myself, okay, why we wouldn't add a plugin to Datadog or ELK, right? Why, don't know. I'm just observing this part of the market.
I fully agree. And what we have often done is we use open source packages who take away a lot of at least the part of creating these metrics, so computing these metrics in an effective way. That is something that you very nicely get out of existing open source packages usually. But you can also just use that and plug it into Datadog, plug it into any other solution. And through that, actually, you can get the best of both worlds to a good extent. And I would also recommend that this should always be the way to start. Look at what tools do you currently have in your company? Do you have Datadog? Well, then don't from the start think about what MLOps tool do I now need? Because most likely you can cover, let's say 80% with your existing stack and the open source tool or a small custom implementation.
I'm also looking at that from perspective of what you would do. Like, let's say that there is an alert, okay? There is some anomaly detected in data. What you can really do, this alert is happening at 2 a.m. Are you going to wake up data scientists and ask her to rebuild your model, or what you can really do?
Yeah, data scientists, I think, are usually not used to being on call during nights or weekends.
Exactly.
So it would be a tough culture shift.
But okay, let's not get into it deeper. So I want to do kind of a step back and get back to higher level again. And okay, we had a team, we have data. Maybe you are monitoring data or not, quite like at the beginning, not. You, in one of your blogs, you defined something like vertical prototype as a way, like it was an answer for a question, how we can go to production. What is the right strategy when it comes to going to production with a model? Can you elaborate a little bit more on it?
Yeah, so when I wrote, and also when I do conference talks and I speak about vertical prototypes, then what I'm referring to is a philosophy of how I believe, not in every case, but in many cases, you should approach building a model. So when we think about how a model is usually being built, what are data scientists also trained? How are they trained to build models? Usually what data science are being trained at, and I was trained like this as well at university, was get that data, take a notebook and build a model and carve out your test set, do your tenfold cross-validation, take care of the imbalanced data, all these things, and then build your model and optimize. Optimize what I call in vitro. So like in a lab, you're optimizing in a lab and optimizing and optimizing. Sure. And then at some point you say, I've hit, this looks good, F1 score 89%. Let's now take this to production. So then, right, either you throw it over the wall to your engineering team or whatever, or maybe you have some people join you, maybe you have a cross-functional teams, and then you start deploying it to production. Often that still takes organizations quite a while because it's still not something that is super regularly done in many organizations. And then after, let's say, half a year, finally this model is in production. Well, and then hell breaks loose, stuff doesn't work. Of course, you don't have that feature in production, or that data quality isn't that good in production, and then stuff starts breaking. So this is what I call doing a horizontal prototype first. This is, I think, how you should not approach building a model, because you're going all in, all that effort, and then, but you're only measuring what matters. You're only getting to what matters at the very end, actually. If you then fail, you've wasted a lot of time, a lot of effort, and a lot of motivation of people. So this is what I believe you shouldn't do. You should target vertical first. And with vertical, I mean, better not focus on the model first. Better try to build your skeleton, your end-to-end solution with a very, very bad model, dummy model, a random classifier, whatever. Do that first. Deploy it to production in a shadow mode, let's say. But start to see how does it react, right? How have real data flow through it. And then iterate on it. Start iterating on your model versions. Start adding features. And observe continually what's the behavior in production, actually. I think that really gives you, starting like this, gives you a handle, on business value relatively early in your process. And that allows you to not optimize in a lab for months, but really optimize close to what matters. And it also allows you, well, to really tell, am I on the right way, or am I working on something that's potentially really not going to work and should rather scrap it and work on something else? So that's what when I say build vertical prototypes, I mean, go vertical first, push through, get your hand on business value, actually, get your hand on the user, and then iterate, then optimize your model. Don't do it the other way around.
I definitely see the benefit of this approach. Something that came to my mind is a question, we did this, right? Like it is a question, it is my follow-up question. What does it take to implement vertical prototype? Because if like this whole, because you need to connect it to you said shadow mode, but still you need to engage your engineers, your DevOps engineers. It has to be part of the product. But what if the best model we can really get is still not enough? So, and you shouldn't assume that you would go above the accuracy from the in vitro stage. It is the most optimistic benchmark for your model. But yeah, like we don't know whether the model would be good enough or not, even after a couple of iterations. So what does it take to introduce vertical prototype? What is included?
Vertical prototyping if you do not have a good modeling platform, vertical prototyping is very expensive, right? For a model you haven't even, let's say, properly started. Maybe you've spent a week or two on it. Going all the way to production, if you need to build this custom every time, you can completely forget about that. That's way too much effort. So in order to do vertical prototyping well, you actually do need a strong modeling platform. And with modeling platform, I mean, you do need people who have who have the knowledge of MLOps, who can automate the very most of this process of going from a model to deploying it and serving it. That needs to be automated to a very large degree. So usually, currently, when you look at organizations, how model productionization is being done, it sometimes feels like a 1900 factory. It feels like you need 10 people. You need to throw it from one person to the other. Everyone does like 2 pieces. It's quite a complex process, manual process. If you have that, you can't do it. You really can't do vertical prototyping. It's too expensive. What you need to do is you need to understand your processes. You need to streamline them and automate them. Then you have a 21st century factory, and then things can work very fast, right? Again,
so it sounds that it is a good strategy once let's say you have some models already in production. Because of that, you have established platform team, right?
Yes.
So for the next models, it sounds like sounds like the right approach.
Correct. You need a strong platform that makes it easy for you to go from a model, an experiment, right, some model artifact, to it being served in a production environment. And that's also what I see as fundamental reason why MLOps exists. MLOps should do that. It should make your path from idea, from POC to production. It should make it fast. It should make it effective and efficient.
Got it. So going a little bit step kind of deeper and forward. So one of the way how data scientists, like here, I'm not sure whether it's data scientist or ML engineer, who is passing not a model, right, singly trained model, but rather a pipeline from development to production. I've read your blog about your experience with AWS SageMaker pipelines. And like starting, from the very beginning, how would you define pipelining framework, why we need it, and what is pipeline role in a vertical prototype?
Mm-hmm. Yeah. So how do I define a pipelining product? So pipeline, I think, is an incredibly overloaded term when it comes to not only, everything engineering, but I think everything data even worse.
Let's go with MLOps pipeline. Oh, actually, it's not sure it's even MLOps pipeline.
I would say data-centric pipeline, at least.
Okay.
That is, at least I make the split between CI/CD pipeline or build and deployment pipeline and anything that takes care of orchestrating your data workloads. That's in my mental split between things. So the way I see a pipeline, especially in a data context, is really a way how you can construct and that sequence can also have parallel steps of jobs, right? It's a DAG you're constructing. That's what a pipeline is. So you have, again, a concrete example of a simple machine learning pipeline would be a training pipeline. Let's say you would have the first step saying, let's load some data from my data warehouse, for example. Then the second step says, okay, let's pick up that loaded data and let's do some pre-processing, right? Remove some null values and that stuff. Then you have a step that says, oh, let's do feature engineering. We could parallelize that. We have some expensive features to compute. So we have 5 jobs running in parallel, computing different features, and then we join them again in a step. And then you have a training step. And that finishes with checking in your model into the registry. Let's say that's your training pipeline. It's really a DAG. It's a directed acyclic graph.
And we have like frameworks, tools that are named themselves as ML model pipelines solutions. So what is so special? Like it is a DAG, right? We have
Absolutely.
more generic Apache Airflow. I know it's used in ML as well, but why we need specialized pipelining solutions once we have more classical ones, generic ones?
I think Airflow is a great example. Airflow, I think my feeling is you find it like in every second company, there is at least one team using Airflow, and there are good reasons for it. It's incredibly flexible. It has been there for ages. And I think if you have Airflow, you probably don't really need a machine learning focused pipeline in that sense, at least not an additional service or product. With Airflow, in principle, you can do anything you want, but it will require bending it quite hard here and there, or it will require, again, quite some custom stuff you need to build. It's not going to be as easy to use for your use case because Airflow was not built for a machine learning use case. So when you compare it to machine learning pipeline frameworks, for example, MLflow pipelines, I think has been released in experimental mode like 4 months ago or something. It's from Databricks, of course. And then you have SageMaker pipelines. In my case, we are working heavily with SageMaker pipelines. But then you also have Kedro, for example, and a few others. When you compare it, these products were built for other users and for a slightly other use case. The concept of the DAG is the same. You're still composing your DAG. But what you get out of the box probably helps you do things a lot faster than you would do the same thing compared to you doing the same thing with Airflow. For example, because I know SageMaker pipelines by far the best, you have dedicated hyperparameter tuning steps. You have a dedicated register model steps that you just say register this model and it's going to take care of all the rest. You have dedicated evaluation steps. Train test splitting is really, really easy. It just takes away a lot of effort, but you don't really need it if you have Airflow.
So it is kind of higher level abstraction over lower, like we have, it started from TensorFlow and we have higher level abstraction libraries on top of TensorFlow, like PyTorch, for instance, right?
Yeah, so definitely I also see it as a more specialized version of a DAG. I see Airflow as quite general purpose, and there are a few other more general purpose ones. But then I see if you go more specialized, it's gonna help you do your thing faster. But also if you do using SageMaker pipelines, let's say only for your data pipelines, probably you will have to bend it there again. So if you want to do everything specialized, you're probably going to end up with 2 or 3 different pipelining frameworks, or you could just use Airflow for everything probably.
Got it. So talking on SageMaker pipelines, for instance, I've met, I will call it 2 clusters of jobs to be done around pipelining frameworks. On one hand, what you can call is Kedro call it a pipeline authoring. Mm-hmm. So it is a process of a way of defining a pipeline, right? We are not executing it yet, but defining steps, conditions, etc. Like defining these DAG. On the other hand, we need to be able to execute the pipeline. So let's call it pipeline executor or orchestrator. And very often those 2 are connected. What is your take on that? Should it be connected? I'm not sure. Maybe SageMaker pipelines works GCP or on-prem. I don't know, but I rather doubt. If we had it split in this way, we could potentially have one like code and execute it on different machines. What is your take? How it should be done?
Yeah. So unfortunately, SageMaker pipelines can only be executed on SageMaker. So yeah, I think that also really highlights the major downsides of SageMaker pipelines, but also, right, you also have Azure ML, and so also another way how to author pipelines on Azure, the same for the GCP. And I think that also highlights really the downside of these frameworks. What you said is, yes, you are locked in. You're completely locked in, essentially. You're binding yourself to that specific provider. And so I think that is a major downside. Upside is, well, of course, integration is as good as it can get with your provider. So I think that is something you always need to see the larger context. Is my company locked in anyway, right? Is this going to be really a problem, or do we have way bigger problems if you really want to migrate away here? I think that is one thing to think about, but also what you mentioned, so pipeline authoring tools allow you for more flexibility if you want to switch vendors. A good example is SendML. The SendML, I think, has done a magnificent job of really providing one way how to do it.
And working on integrating ZML, integration of ZML with Neptune as we speak. I like them as well.
I think that is a super important step they are taking, simply because if you have a more abstract layer that allows you to easily plug in other executing engines, well, that gives you a lot of flexibility, a lot of freedom. But also, especially in larger organizations, you often do not only have one that infrastructure, right? You probably have 10 business units and you have 8 different setups in there. And there also, that stuff becomes quite relevant. If you want to move certain things across boundaries, organizational boundaries, that really helps you do this. Otherwise, you can rewrite your entire thing almost.
For me, it is also painful because I'm looking on MLOps from software development perspective because it's my background. And I don't remember exact statistic on that, but like it's definitely above 50% of the code developed by software engineers is copy-paste from GitHub or other public repositories, right? So if we wouldn't have generic, more infrastructure agnostic pipelining framework, it will limit a little bit what we can build on top of that, because each provider would require different implementation. Anyway, let's see how it will develop. They will come up with like Kubernetes, of course, initiated by Google, but today is a infrastructure agnostic way how we operate clusters.
Yeah, we have, for example, we are heavily using SageMaker pipelines, really basically for everything. For us, the contract is you want to deploy a model, the contract is it must be a SageMaker pipeline. This is the artifact you basically submit to the platform. But also, we have been thinking about also adding a layer in between, right? In terms of, we've also been looking into SendML, of course. It's not quite our need, not quite our use case, because we do not have this heterogeneity at all, and we also don't expect it. But having that a layer on top, what a vendor provides you, it also gives you more room to, for example, make future migrations of models just a lot smoother, right? Your users don't care anymore where this actually runs. You as a platform team, you can modify this layer, manage this layer in a way to introduce changes, introduce, I don't know, different encryption keys, whatever you need, whatever you want. This gives you the flexibility, actually. If you went, let's say, for CNML, which is basically another provider on top of open source package, right? A provider on top provider. Yes, you're getting the independence, but you're still not getting the flexibility to do whatever you want. So I think the CNML use case is a great one for giving you flexibility. But I think for really mature platforms, you always want to think about adding at least a thin layer on top of whatever external tool you're using to really abstract away the complexity that your users shouldn't see and to infuse the settings, for example, that you need for your current state.
Got it. Is a question related to pipelines? You said that pipeline is something that you submit. It is the protocol of giving the model. You're giving pipeline to production team. So why we are talking about model registry and not talking about pipeline registry? If it is the protocol, what model registry does then?
Mm-hmm. Yeah, it's a very good question, actually. So I've been thinking about that a lot of times. So in one of my credos is pipeline everything, right? If you start building a model, pipeline it. Whether that's a scikit-learn pipeline, whether that's a SageMaker pipeline it. It makes it pickle your artifact. It makes it reproducible. Do it. So I agree. Why call it model registry, not pipeline registry? Well, a pipeline, the model registry, the way we use it currently, is really focused on that model artifact. And it gives us the links to the pipeline that produced it. So basically, it's one of the outputs of that pipelines. And what we try to do is we link back every single artifact produced to that specific pipeline. And that pipeline holds all the information about what jobs were in there, what images were used in that pipeline, and so on. So we can basically suck it all together into one big picture. But I do agree that this is how we're using it. But personally, I would be a lot more happier if it was a pipeline registry, giving you a nice overview of pipelines and the model artifact being one element of it with all the associated information, but also data used or data produced being similar, as important as the model actually also declared, enriched with information in that registry. Actually, that would at least be my dream of a model registry, which is not a model registry anymore, but a pipeline registry.
Because currently model, like maybe use a different one, but the model registry solution I've seen, we to some extent at Neptune, we also provide it to some extent, but it's more focused on how it was built. So more on the pipeline than on the artifact of the model, right? But they're more model centric. And what I was curious about is why we even need it if we have, if we are registering just final artifacts, the weight of the model, maybe plus some information about signature of the model, why we cannot use, let's say, Artifactory or Docker Hub for storing just artifacts. Software solutions are here.
Back in the days, that's how we started in 2017, 2018. We were using Nexus as an artifact store for our models and all the metadata. That was fine, right? I mean, it's not a nice way you don't have a nice graphical user interface with seeing how have your metrics for that model developed and potentially bias and fairness assessments you might have attached. My view is this is kind of where model registries are developing, right? It really seems to become more, not so much about the artifact itself, of course, but really more enriching it with more and more information about the model, but also about what happened before and hopefully not, I don't see that yet that much, but hopefully also what happens after. Personally, I would actually love to have it as a cockpit for these are your models, this is where they are running, this is the data they are consuming. But then it would be, as you said, more a pipeline registry or a service registry or whatever you want to call it.
And I think it is connected. So we have a pipeline. And in this pipeline, very often we are training or retraining our models or doing HPO or so training many models, right? How do you monitor pipelines? How is it connected? How is it different from experiment trackers? What is your experience here? What is your stack here?
Yeah, so we are, as I mentioned before, we're using SageMaker pipelines. We are for monitoring pipelines. So we differentiate between different types of monitoring there. One thing is really more the operational side. So meaning for a given pipeline, how many jobs are in there? How long did each job run? Was a job successful or stopped, or did it fail? Why did it fail? How many? This is kind of more the operational side of it.
Kind of infrastructural part of it.
Correct. That's really the infrastructural part of it. That is one element that we are monitoring. We are also then monitoring, and that is then the infrastructure side. We're monitoring out of the box for everything, for every pipeline that runs, because that is right. It applies to every single pipeline. But then there is also more the logic part that you want to monitor. So more like, validating certain assumptions, for example, right? We talked about data monitoring before, and that's then what happens in our case inside that pipeline. So as MLOps platform team, we provide capabilities to make it very easy to monitor the metric that you are interested in inside your pipeline, or to profile your data. That's then automatically also pushed to a monitoring solution, and you get your dashboards, some parts of it out of the box, and the rest you can customize as you want. And then you have your full picture of the operational metrics, success, failure, how long, and so on. But also you have the picture next to it about how many, in our case, alerts were produced, how many positive predictions, how did that variable develop statistically, and so on. So you have all that, and this is all that in one dashboard, and that's our pipeline monitoring, kind of.
Okay, and do you see a use case for, like, would you use experiment tracker here, or you would put it rather, you'd keep it just to pre-production period phase?
No, so actually we use experiment. We automatically attach an experiment tracker to every single pipeline that we launch without the users even seeing it. So that means there is at least a very minimum set of things is being tracked for every single pipeline. That experiment config can then be extended by the user, adding a customized experiment config, and that is then being run every time you trigger your pipeline. So in principle, we see experiment tracking as something that should be usable together with the pipeline, because that's also what we recommend. Use a pipeline to track your experiments, because that's how you ensure it's reproducible. It's a lot harder by just running your notebook, but also experiment tracking should serve you also in a notebook setting. I think it should cater to both.
Got it. Okay, Simon, so my last question would be a question that I'm asked by, I told you that I have a lot of friends in classical software engineering. So I hear it more and more often that DevOps engineer or senior DevOps engineer was asked to operate model in production, move model to production, or get interested with MLOps. And they asked me what they should learn, what they should do in order from being top senior DevOps engineer. You have A player, and the person wants to be A player MLOps engineer. What would be your recommendation? You're MLOps engineer.
Yeah. I think when you're a senior DevOps engineer, I think you have really a great starting point to, I think, transition, or I wouldn't even say transition, because I guess DevOps is still going to be like 70% of your work. So it's more like to add that ML part of knowledge that you are missing. And I think actually really that's what you would need to do. You really need to start with learning data science. You need to fundamentally, for a successful MLOps engineer, is understanding your users, understand how data scientists work, and understand their needs. Because from a building perspective, that's probably not going to be what's going to be challenging for you if you are already a senior engineer. I think it's a lot more acquiring understanding for data scientists. And that is best done by doing courses, right? Starting with, what's a linear regression? How do I actually build a model? What are the packages that I'm using? How do I package my models? How do I evaluate them actually? What are the challenges there? How can I, building out the pet project, let's say fully automated system that we train a model, it's being deployed, it's being served using some public API, perhaps some Spark streaming to it that pings your deployed model, and then monitor some metrics in there and re-trigger your training once the metric exceeds a certain threshold, right? So cultivate the pet project where you're going to feel very comfortable on the DevOps stuff, but you're going to see that it's going to become more challenging actually on the data science part of it. And so I would really recommend doing that.
Do you see, like, okay, we have the person have learned it, right? Started operating first models. What do you think about collaboration between MLOps engineering team and DevOps team, especially in the context of, let's say, a SaaS startup? It can be later stage startup, but we have a SaaS solution. It is our business. we have there some 10 ML models operating on production. Do you think it should be in this setup of a startup like that? Do you see it, DevOps and MLOps being kind of one team, or you would recommend to have two teams organized a little bit differently?
I think in principle, these two parts are very, right, they have a big overlap and they are operating based on often to a large extent the same background. They're operating using similar tools, or at least they should in the very beginning. So depending on the size of the teams, if you can be one team, why not? Especially because you're both busy building automation for users. The main difference is who are your users? So I think when the team size permits, I think it makes a lot of sense keeping these people close. You could also think about having two arms of one team or so, more like two specialized parts. So you keep below the often recommended 8 people per team size or something. I think that can make a lot of sense. I think at TMNL, what we are doing is we have also thought about that in some parts, because we also have more a classic platform cloud engineering team, which is a lot more, most of them are classic DevOps people. In our case, I think we are not one team because our teams would be too big, but we do share. We have overlapping crafts actually. So that means we have a few people who belong to the DevOps craft, but working in the MLOps team. So that means we try to strengthen the links between these different roles through having crafts in there.
And in the organizational structure, if you can share it, who is, I'm not sure it's called lowest answer. Basically, we are looking for managers of managers, where they meet. Who is what is the
we have a very flat organization. Right now, we are like 70 people, and there is one line manager. That's the C-level.
Okay, so there is no kind of CTO, right? It is
correct.
The person.
Correct. The CTO, everything comes together. Of course, there are the tech leads. That's my role, but it's not like this is where you have technical responsibility, but you're not the manager.
Got it. Simon, thanks a lot.
Thank you.
I really enjoy it.
It was a pleasure. Yes, absolutely.
MLOps Live is brought to you by Neptune.ai. Remember that you can join us live at the next event and ask your questions. And you can register at neptune.ai/events.
And then make sure to search for MLOps Live in Apple Podcasts, Spotify, Google Podcasts, and anywhere you get your podcast. Click follow and don't miss any episodes.
Thanks, and see you next time.